Yes, sir.
Okay. So P represents propagation, G represents generation, and C represents carry here, right? And phi should be the clock input. So in that way, the circuit can easily distinguish what will be the output carry or C4 when you give some sort of inputs, right? Whatever in P naught and CIN will be representing the there will be some voltage across this node, particular node. So for getting some voltage in this particular node, you should know what is G naught, what is P naught, and what is C input. That voltage will that voltage and P1 and G1 will determine what will be the output in this particular node. Then that voltage and P2 and G2 will decide what will be the output of this particular node. P3 and G3 and this voltage will determine what will be the voltage in the output node. So as the final carry. So this particular carry generation formula carry look ahead from P naught, G naught and C input, you can determine what is C4. So the C4 formula is given here. So this kind of formula will be given to you maybe in the exam. What you need to do, there will be sort of binary data. For example, G1, G3 and P3 will be given in binary format. Binary 1-0 format. Then what you need to do, or G2, P2, G1, P1, G0, P0, and C input, based on one input carry, you have to decide the final output carry in terms of binary digit or maybe in terms of the waveform. Okay. So I recommend you should study both. If this kind of circuit will be given in the exam, you have to study both, either using a waveform, how to get the C4 waveform, giving given the all the input bits, like from G naught and P naught C input to G3 and P3. So from there, and obviously clock is an important issue, right? Without clock, there should not be any sort of C4, right? So you have to be careful. So this is one of the examples you can try before going to exam.
So do we need to find the equation as well, Nakita?
No. Equation will be given. Equation will be given. What you need to do, you need to calculate the C4 either using digital data in truth table or maybe waveform. Understood, Jamil?
Yes, sir.
Okay. Do you remember what type of circuit this one is? Anyone can remember the circuit?
Sir, is it a shift register?
It's a D flip flop. Now you can imagine this is a D flip flop.
Yes, sir.
You have a Q and Q inverse output, right? So all you need to do, you need to know the input bit clock. These two inputs are required to get Q and Q naught, Q dash or Q bar. Is that clear?
Yes, sir.
Mm. So this is straightforward than this one. I mean the carry look ahead. It's very simple. Just maybe in the exam I will be giving you the D and the clock. Based on that, you have to draw the Q and Q bar. I mean Q and Q bar are just the opposite, right? Waveform. So you need to draw the Q waveform or you need to draw the truth table. Okay. So we study four types of shift registers, right?
Yes, sir.
Okay. So So from adder logic, there will be one full question of 30 marks. I will give you 3 questions. We'll give you I will give you 5 questions. You have to answer all 5 questions. Every question will have A, B. Only one question will have A, B, C. Is that clear?
Yes, sir.
Okay, please note it down because in the I cannot write it here, but you can remember like that way. So from your adder logic, you will have a full question, 30 marks question. Okay.
Yes, sir.
Then shift registers. So how many types of shift register we studied? Serial in, serial out, right? SISO, SIPO, PISO, PIPO. That 4 types of shift registers we studied, right? Also, I gave that kind of question in our previous year exam, like a shift register depending on load or shift or load inverse signal, and also clock. You have to determine the outputs from each and every D latch. For example, here the circuit will be given, or maybe this kind of symbol will be given. You have inputs D0, D1, D2, D3, and you have control inputs like shift and clock. Based on these 6 input data, you have to calculate what is Q0, what is Q1, what is Q2, what is Q3. So if it is serial in, serial out, you need to draw that one. For serial in, serial out, for parallel in, serial out, you have to draw that kind of waveform. I did examples so many times. I spent some time to explain the circuit, also gate level circuit. So maybe you can distinguish the differences between 4 types of shift register, and also you can be able to draw the waveform. So to this particular exam, I will try to emphasize more on waveform than the truth table. Okay. So the truth table one, I gave it here in like slide number 5. You can see how serial in and parallel in, serial out data shifter works when shift or load inverse is 0, or if shift and load inverse is 1. Okay, so how to load the data and how to shift the data. So that kind of understanding I think you have during your class. So what you need to do, based on the given control inputs and data inputs, you have to draw the output data. You have to draw the output data for D1, D2, D3, and D0. You have to draw the Q0, Q1, Q2, Q3. This kind of waveforms, or maybe this kind of digital data you have to draw. Is that clear?
Yes, sir.
So from shift register, there will be one question from shift register. One question, 15 marks will be from, or maybe 15 or 20 marks from this kind of shift register operation. So the chapter right after midterm was adder logic. So one full question from adder logic, and 20 marks or 15 marks question from this particular shift register. Then in shift register we also studied the ring counter and Johnson counter. You can remember, right? So
Yes, sir.
I believe you started study. So ring counter and Johnson counter also we studied before, right? You should know the difference between ring counter and Johnson counter, their operational principle, and how to achieve the data shifting based on ring counter and Johnson counter. So slide number 6, please study carefully. Okay. Okay, so you remember we study BiCMOS in 2 lectures and 1 lecture of gallium arsenide MESFET device. You remember, right? There will be one full question on BiCMOS and gallium arsenide device, 30 marks question. So here is one of the examples, like why BiCMOS is faster than conventional CMOS. What are the limitation of conventional CMOS? What are the advantages of BiCMOS? What could be the disadvantage or limitation of BiCMOS? So these kind of things you need to study. Things are given in the lecture note, but maybe the questions are conceptual. So you have to understand why there should be some voltage drop across the Q1 transistors. So Q1 is BJT transistor, Q2 BJT transistor, and T1 and T2 are the MOSFET transistors. So this is completely CMOS part, and this part is BJT part, right? So you need to know the operation of these particular circuits. So one could be like this kind of question. Maybe some of you already studied the previous year question. Anyone in this class? Jamil, did you get any question from previous year students?
No, sir.
Not yet.
Not.
So I in the class I mentioned that um, why um, BiCMOS VTC curve, in BiCMOS VTC curve, why at low V input there is a voltage difference between V output. See, the CMOS has higher V output than BiCMOS at low input voltage. At high input voltage as well, the conventional CMOS has almost 0 volt output at higher v input. However, BiCMOS has a certain voltage drop. So definitely you understand the drop is due to the voltage drop across the BJT transistor. So there is a distinguishable difference between BiCMOS and CMOS in the BTC curve. So why it happens here? Okay, so you should understand this kind of question for your exam. So why BiCMOS voltage swing is smaller as compared to CMOS voltage swing? Okay. I spent some time to explain this one as well. So here is the answer. The output is not exactly VDD, rather than you have to have 0.7 volt drop across the Q1 voltage, Q1 transistor, or maybe Q2 transistor. Okay, so this kind of examples you should definitely study for your final exam. Gallium arsenide device, they overcome that kind of overhead transistors like 2 additional BJT transistors. They consider a depletion mode an enhancement mode transistor of same material, right? Why gallium arsenide? Why gallium arsenide devices or maybe MESFET devices are preferable than conventional CMOS or BiCMOS? Did you study those things? How to develop the logic, inverter logic from this particular circuit?
Not yet, sir.
You should study. So in MESFET device or direct coupled the transistors, field effect transistors, so they are faster than conventional CMOS. Okay, so faster and then highly sensitive, but they have limitations like costly. Okay, so 75 millimeter wafer cost $100, whereas 200 millimeter wafer cost $10 when it is silicon based wafer. So fabrication step more, you need more fabrication steps, that means more money, more precise application oriented, for example satellite communication and other military applications where precision is highly desired. RF circuits, like communication circuits, you should definitely consider this sort of gallium arsenide device. So combinedly, there are other topics as well. So combinedly, BiCMOS and gallium arsenide will have one full question of 30 marks. Okay, so if you see the topics on the BiCMOS and gallium arsenide devices, it's not only circuit but also you can see the devices, the explanation of device, working principle of the device, comparison of the device with conventional CMOS. There are so many topics. So please study BiCMOS and gallium arsenide carefully. No fabrication part is included. However, conceptual question about the device itself and circuit you should know, but not big circuits, small circuits. Okay, so the one announcement is you should exclude FPGA from your syllabus. Okay, so that part is not going to come in the exam. FPGA. Okay.
Okay, sir.
So we have I just said about two full questions and 50% question of shift register. So another part is from data path. You remember the data path and functional units. Jamil, you remember we had some topic called data path and functional units, like how data shift. So here is a data shifter, right? So one stage data shifter. So based on shift command, the data can be loaded or maybe data can be shifted. So when the shift command is 0, maybe data will be loaded. X2 will be in the Y, X3 in the will be in the Y3, or X2 will be in the Y2, or X1 will be Y1 and X0 will be Y0. This sort of data shift.
So will data path have a separate set of question or is it included in the shift register set?
Shift register and data path combinedly one question. Okay.
So we did this in the class question.
Yes, you did this in the class, but it's not only one bit shifter, multi-bit or multi-stage is also possible. Like shift command maybe for two stages or multi-stage, right? S1, S0, that sort of data shifting also is studied. So what you need to do, you need to know that how digital data can be transferred. So if X0 is one, so what will be the Y0? When X1 is 1, what will be the Y1 or Y2 or Y3? This kind of data shifting you should know. And also you can see here on top, below that red dot, there is a ground connection, right? The rightmost AND gate is one of the inputs is the grounded, right? You should know how this ground may impact on the shifter performance. So there are so many interesting understanding of this circuit. So those who studied or those who were in the class, I explained these things to you. So please prepare yourself accordingly. Okay. So multi-bit shifter for using one shift control or one shift command or the signal, or multi-shift command signal like S0, S1. There are some block diagrams as well, so please read those things. So data path and functional unit plus shift register combinedly will weight one full question of 30 marks. So as of now, I already explained total 90 marks question. Any questions so far?
স্যার রিং কাউন্টার আর জনসন কাউন্টার এই
Yes.
পার্টটা এটা কি শিফট রেজিস্টারের সাথে থাকবে?
Yes, definitely. The topics included in the shift register you should study.
ওকে স্যার।
Any further question? All right. Then in the shift, the data path, you also know what is called barrel shifter, right? Barrel shifter, how this 4x4 transistor array or total 16 transistor array can control shifting the data using 4 shift commands. Shift 0, shift 1, shift 2, shift 3, right? SS0 to SS3. So all the commands are connected through the gate electrode of the transistors. So they are not straightly connected, they are crossly connected. So barrel shifter, how the A3 will be shifted based on the shift command, like 1 bit shift, 2 bit shift, 3 or 4, depending on the values in S0, SS0, SS1, SS2, SS3. So please study those topics carefully. So I completed 3 question related topics. Now, memory. Okay, so do you remember the SRAM and DRAM we studied?
Yes, sir.
So what are so there were some advantages of DRAM than the SRAM, right? In terms of refresh rate, in terms of speed. In terms of speed, static RAM is good. In terms of storage, the DRAM is good. When you need main computer memory, definitely will consider the RAM, the DRAM as compared to SRAM. Less transistor count, but you need a highly capable large value capacitor, right? So that capacitor will definitely consume lots of uh, layout area. So capacitor is not always good for, it's not area efficient design component. But to store the data, because that is only one transistor, 1T1C. So you should have a capacitor because transistor cannot hold the data for a long time. Whereas in SRAM, you need more transistors than DRAM, but here you have 2 bus transistors and 4 transistors. Basically, they form 2 connected or inversely connected inverters. Like T1, T2 will be one inverter, T3, T4 will be another inverter. This is called cross coupled inverters. Okay, so you should know the sensing mechanism, how data is stored. You should know how SRAM store the data, how DRAM store the data, why DRAM speed is smaller as compared to SRAM. SRAM is larger than DRAM. Higher speed or speedy than DRAM. Why? How to get the data from SRAM, how to get the data from DRAM. So those kind of mechanisms should be studied, not whatever I wrote here. Attributes like general information, application size, cell complexity or cell size, cell density, speed. Not only this, maybe you should definitely know how to sense the data, how to read the data in SRAM, how to read the data in DRAM, because those things I explained in the class. Why the capacity in capacity point perspective? Here it is mentioned that only the SRAM has 16 MB data size as compared to DRAM. DRAM has 16 GB or even beyond data size. So why DRAM has larger capacity to store large data as compared to SRAM? You should definitely know. Okay, so one full question from the RAM will be in the RAM or ROM programmable devices. Programmable devices, PLA, PAL, and flash memory, some sort of simple PLDs, programmable logical device, or CPLDs, complex programmable logical devices. I explained to you these topics during the class. So this is an example, slide number 13. Example, like you have inverters, right? You have inverters, you have AND array logic and OR array logic. Here, this is AND array logic, or array logic, right? You have 2 OR gates, you have 4 AND gates. And to read the data from the output, you have XOR logic. So all you need to do in the exam that write, if I ask you to write from this or maybe from different circuit, if I ask to write you the expression of F1 or F2, you should write. Then I may ask you what are the need of this particular 0 and 1 bit, okay, how they control the performance of this particular PLA. So that part may not be written in this particular figure, but when I explain those things. So what are the purpose of using 0 and 1 control bits to realize the F1 and F2? Okay, so you should definitely know those things. This is another example of PLA as a ROM. Maybe you know better than me because you studied, I studied 20 years ago and you just studied 2 years back. So very recently you studied the digital electronics. So you know how to minimize the length of the expression. Like if you add all 7 different outputs from these AND gates, like this one F2 will be addition of A bar, B bar, C to ABC. So when you add all those things, you can simplify that as A plus B plus C. Or maybe when you add those 4, that will reduce that. It will be like A XOR B XOR C, sort of expression. So this question I asked during the last final exam of your seniors. So they had to write down the expression for F1, F2, F3, F4, and F5 because that was a closed book exam. So they had to do it by themselves. But because this is an open book exam, all you need to do, you need to know how to derive the equations and then how to reduce the expression. And maybe not this sort of truth table, but maybe waveform can be asked from you. 1 means ground and 0 means ground and 1 means 10 volt, something like that. So you should definitely draw that one. So from programmable logic, another topic is CAM. You know what is CAM? Content addressable memory. Did you study that? Differences between traditional memory and content addressable memory. Students, you are there?
Yes, sir.
Yes, sir.
আগে কখনো এটা করিনি।
কেন?
We didn't have this in any of our courses. মানে এই কোর্সে করছি, other daily
That one, that's okay. So CAM, what is the difference between CAM and traditional memory? So in traditional memory, the computer system will provide you the exact location of your data, like 0, 1, and the another sensing array or sensing element will sense the data in that particular location, like at 0, 1 location. What will be the data? The data is 0, 1, 1, 0x. Okay, so that is our conventional way to search the data. So, but in CAM, the computing system will give you the data, and based on that data, you have to figure out what is the storage. So the storage may be so see here 0, 1, 1, 0, 1, 0, 1, 1, 0. So the first 3 bits are the same, right? First 3 bits are the same, even the 4th bit also same, but somehow data may be corrupted. This is X and X, this is X. So you cannot distinguish the X. So that's why the address could be 0, 1 or 1, 0. So that's why, but because 4 bits are matched, so definitely the output is near to 0, 1. Okay, so this kind of memory, why this kind of memory is important? Because already we had a conventional memory, so why we should also consider a new memory operation like CAM? What are the benefits? What are the limitations? This is a special kind of memory, so you need to explain those things, the differences. Maybe I will ask you with some points, like this is the point. So based on these are the points. So based on these points, you have to write down the differences between CAM and conventional memory. And this is the flash memory. I asked this question to your seniors last year. Also, I explained this during our current semester class that uh, flash memory, how flash memory works. Just write or read or erase uh, using some, voltages in the transistor nodes. Like when you have a 0 volt, you have 0 volt in the gate electrode and 20 volt in the substrate. You just erase everything from the transistor. Or when you have 20 volt in the gate and 20 volt in the substrate, so you started inhibits or started erase process. So it will take time to erase the data, fade out whatsoever. All terminals are kept at nearly the same voltage, so no erase occur. So just going to start, no erase has happened. So this kind of logic will give us like voltage. Sometimes the logic can be based on the charges on floating gate, and that charges on the floating gate will determine the threshold voltage. So if you have negative threshold voltage, that will say you have logically high. Logic high means 1. Or if you have a positive, if the transistor has positive VTH, then you can determine that this is logically 0, or vice versa. So this is not an exact rule. You can also implement your own type of logic. Sometimes negative VTH can be treated as logic 0, or maybe positive VTH can be treated as logic 1. So that's up to you. I'm not dictating you, just you can implement your own logic. So this kind of memory is called the flash memory. Okay. So all together, like conventional RAM, ROM, PLS, PLDs, application of PLDs, application of memory, memory access technique like CAM or flash memory. So NAND memory, you remember NAND memory, NOR memory?
So one is serial, another is parallel.
Yes, in NAND memory, you have transistors which serially connected. So you have only one bit line and one source line. That's all. Very less number of interconnection needed. Whereas the NOR flash memory, here, it's written flash memory. That means you provide certain voltage in the source, certain voltage in the drain, certain voltage in the gate, and certain voltage in the substrate, so that you can store some data. Okay, so for the source line, you should, for this, when it is NOR logic, so all sources are connected with a source line. Bit line, all the, drains drain electrodes should be connected using one line, that is called bit line. And one memory cell will have two other connections like gate and substrate biasing. So all the transistors are independently biased. They are not connected each other directly, rather than bit line and source line connection. So more number of interconnections needed here. And also because two lines, parallel lines needed, so memory size will be larger, unit cell size will be larger. So these things you should keep in mind. The difference in when you write the differences between NOR flash memory and NAND flash. Okay. Okay, so we study so many topics of RAM or memory, and from memory there will be memory and the this CAM or the content addressable memory. This kind of topics will wait a full question of 30 minutes. Okay. So you should know the device, the control gate, and the floating gate principle, how they work and how they store data. Okay, based on the flash memory conditions. So these conditions already given on the slides that you are going to print and take it with you. So you don't need to memorize those things, but you need to explain the device or explain the memory circuits. So memory and programmable logic will combinedly weight around 30 marks. So I just explained 4 questions, full 4 questions. And the last part is IC packaging. You remember IC packaging? There will be at least 50% marks from IC packaging. So until now, do you have any question?
No, sir.
Okay. So during the IC packaging class, I explained the connections like level 0 to level 5 connections for interconnections for IC package. Just a moment. Assalamu alaikum. জি ভালো আছি। হ্যাঁ, আপনার সাথে কথা হয়েছিল ভাই। আমি আসলে ক্লাস নিচ্ছি, তো স্টুডেন্টরা বসে আছে। আমি আপনাকে একটু পরে ক্লাস থেকে বের হয়ে ফোন দিচ্ছি। আসসালামু আলাইকুম। Okay, so sorry for a call. So is there any issue regarding the level 0 to level 5 interconnections within a package?
No, sir.
Okay, so this can be one of the short questions. And we studied what was called DIPs, SIPs, SMTs, these 3 different types of IC packaging technique. You should know the differences between them. Okay, very carefully, precisely. You should know the differences. And maybe I can ask some to differentiate between them with some given points. So you should write them accordingly. And the packaging technique, we studied 2 packaging technique. One was wire bonded package and another one is flip chip package. So in one wire bonded package, you can see there is a wire connected from the die to the PCBs, right? So this was and the backside is ball grid array. So this kind of wire bonding techniques has some advantages and also some limitations. So you should know the advantages and limitations. So I can ask you to draw a different, to distinguish the difference between wire bonded and flip chip package. So in flip chip package, you have some underfill as well to reduce the excessive strain between the balls and the metallic bond pad. So, and what are the purpose of heating or the thermal annealing, those kind of things I explained to you. So please do not forget to revise those things. Okay, this flip chip packaging I also asked last year. I mean last year 23-24 batch. I mean, last year final exam, I asked this question to students, so you can also consult with that question. The fabrication process of this particular IC or packaging process of this particular IC type, like what is called flip chip package, and how it is better than wire bonded package. What are the limitation of flip chip package? Because if you see here, the bond and the ball grid array, they connect. They have a connection, right? So this kind of connection, the gold plated connection, using some sort of metals called gold or some other metals, is complicated. So you should be very careful to explain those topics. And in one slide, this is the last slide. One slide, I had a summary of SOC, MCM, SIP, SOP. So maybe you can see here one complete system on one chip. So you have different type of ICs, optoelectronic IC, digital IC, RFIC, RAM, and physical interconnect. And they are fabricated on top of a single substrate that is called system on chip. Systems on chip. MCM, multi-component, multi-interconnect multi-component module, so MCM. So here you can see there are so many modules, and modules are on top of a single substrate, but substrate and those modules or ICs are connected using some ball grid array. So eventually you can have the same application of optoelectronic IC or digital IC or RFIC. However, the connections between the modules and or the systems with the substrate using ball grid. So that kind of technology is called MCM. What is SIP? The systems are parallelly connected. So see here, they are stacked. Digital IC, analog IC, RAM, or any other systems are stacked vertically. So this is called system in package. And SOP means system in package and addition of MCM. So this first part is MCM and this part is the SIP. So the combination of that, those two will be the SOP, system on package, system in package and on package. So please be careful when you explain the SIP and SOP, or even SIP, S small letter I P. So this is small letter. This should not be a capital letter. This is small I. Okay, so be careful. So combinedly, packaging will give you 50% of one question, so 15 marks. So from packaging, maybe one full question, right? Maybe one full question from packaging, uh, something like that. So total 5 questions from packaging. So that's all. I gave overview and hint. So many hints. Do you have any question about your syllabus? Students, do you have any question about your syllabus? Is understood?
Yes, sir.
Okay. So I think questions will not be so difficult, but not exactly what I given during the on the lecture note. So it will be slightly different. So don't be in panic. Okay. So read the question carefully. All type of hints are given uh, in the question paper, and also I gave hints about the type of questions here. So altogether, please study carefully. Today is 25. Today is 25? Yes, today is 25. So you have, uh, you may have almost 5 days, right? Before exam. So 5 questions, 5 days. You have fair enough time for your revision. Okay. So try to study her, and I believe everyone will get good grade, because not only this exam, mid was good, right? Mid was not so difficult. I believe it was okay, or maybe it was very good for many people. And also you have given the assignments. I will try to accumulate the maximum marks to you on the assignment and also the final exam. Only this part I wish and I seek your sincere contribution. Okay, that will be all for today's class, and maybe the last class of this semester. Any further question to you? Anyone has any question? All right, then I will close the session today. Already I given the slide to you. You remember? Did you get the questions? Sorry, did you get the slide in the Google Classroom?
Yes, sir. Yes.
Okay. Please start study. Okay. Inshallah, it will be fine.
Thank you, sir.
Okay. Assalamu alaikum.
Assalamu alaikum. Wa alaikum salam.
Wa alaikum.